Okay, good morning, good evening, good afternoon, whatever it is. Hopefully you're watching this because you want to know about the discriminant. So, like always, I'm just going to show you some questions, and then I would like you to pause it and have a go at the questions first. So we've got 3 questions on the discriminant, one which we want to know it's got equal roots, one with no real solutions, and one where we have to find when it has equal roots and also solve the equation. So I'd like to pause it and have a go at the questions. And so question 1 says, given that the function f of x, which is sx squared plus 8x plus s, has equal roots, find the value of the positive constant. Well, whenever we're looking at something and it's got equal roots, our main thing that we're looking for is the discriminant, which is going to be our b squared minus 4ac. If it's got equal roots, that means we want our discriminant to be equal to 0. So therefore, looking at b squared minus 4ac, I've got 8 squared minus 4 lots of s, which is a, and s, which is c, which is going to be 4 lots of s squared equals 0. So 64 equals 4 lots of s squared. 16 equals s squared. So therefore my s is going to be equal to positive and negative 4. It says find the value of the positive constant s. So the positive one. So therefore, I'm going to write it out this time for once. S has to be equal to positive 4. So that would be our third question. The next question, find the range of values of k for which 3x squared minus 4x plus k equals 0 has no real solution. So this looks a little bit trickier than the last one. So I'm just going to put a equals 3, b equals negative 4, and c equals k, just so I've got them there. If it has no real solutions, that means I'm looking for my b squared minus 4ac, the discriminant, to be less than 0. So substituting in my values, I get minus 4 squared minus 4 lots of AC, which is 3k, 4 times 3 times k. And I want that to be less than 0. So minus 4 squared is 16, minus 4 times 3 is 12k, is less than 0. I can add this across, so I get 16 is less than 12k. Dividing by 12, I get 16 over 12 is less than k, which I'm then just going to simplify. They're both in the 4 times table, so I get 4 over 3 is less than k. I'm just going to rewrite this because I think that looks a bit ugly, so I'm going to say, therefore, k has to be greater than 4 over 3. I always prefer greater than in my answer. Okay. The function g of x equals x squared plus 3px plus 14p minus 3, where p is an integer, has 2 equal roots. Find the value of p. So again, because it looks a bit nasty, I don't really want to try it without first making sure that I've got my a, my b is 3p, and my c is going to be 14p minus 3. So find the value of p. So I've, again, b squared minus 4ac. And this time, if it's 2 equal roots, I want it equal to 0. b squared is 3p squared minus 4 lots of a, which I don't need to put down, and c, which is 14p minus 3. And again, that's equal to 0. So 3p squared is 9p squared minus, well, 4 times 14 is going to be 56p, and 4 times 3 is going to be 12, but then it's going to be positive 12 equals 0. Whilst I've got this, I am then going to try and solve this. Again, I'm just going to use my calculator for this. So on your calculator, equation, I want a polynomial and it's a degree of 2, where it's 9, negative 56, and 12. That's going to give me a p-value of 6 and of 2/9. Okay, it tells me that p is an integer, so therefore I don't need this one here, so I can just say that p equals 6. That would be part A. Part B, for this value of p, solve the equation. Well, I'm just going to substitute it back in. So I've got x squared plus 3p, which is 18x, plus 14 times 6, take away 3, which is 81, equals 0. And this looks like x plus 9, 0. So therefore I can say x equals -9 because it's a repeated root. And I think that's my last question. Thank you.